Hello friends, today I will discuss about battery bank in a substation and use of tap cell in a battery bank. So in a battery bank up to 20 volt DC voltage, there are 107 or 177 number of cells are connected in series. This cell are connected to the battery charger, so that battery charger will continuously charge the battery bank. So there are three cables are connected from the battery bank to the battery charger. One is the negative terminal, another is the highest terminal or the 107 number of terminal, and another is tap cell terminal. Normally tap cell terminal is connected as a 80% of the total number of cell. Here 87 number of cell is the tap cell number. So what is the function of the battery bank of the substation? So battery bank is connected to the charger, and there are two types of charging mode. One is float charging mode and another is boost charging mode. This float charging or boost charging can be manual or can be automatic. So this charger is continuously charging the battery bank, and therefore each of the cells are charging continuously. Under failure of the DC supply, then battery bank will supply the load to the DCDB. So what are the loads which is connected from the DCDB? Number one, which is control and relay panel for control and protection purpose. Number two, switch gear auxiliary supply for control operation. Number three, auxiliary supply for all the metering circuit. Number four is DC emergency lighting in a substation. So these are the load normally connected from the DCDB. Under failure of the AC supply, battery bank will supply the required DC load from the battery bank. So in the battery bank charger, there exist two types of charging mode. One is float charging and another is boost charging. The charger is supplied with three-phase supply, three-phase AC supply, and these two types of charger will continuously supply the required DC load to the DCDB. And at the same time, these two types of charger will supply the required charging current to the battery bank under which mode it is selected. So the selection of the float charger or boost charger can be either manual or it can be automatic. So there exists one DC contactor which is connected as a C in this figure. So under float charging condition, this contactor will energize and it will provide the required charging current to the battery bank. So there exists a blocking diode, that is BD. Under boost charging mode, this blocking diode will be activated via tap cell. So let us take a quick view of the battery charger nameplate details. Here the input supply is 400 volt, and there is a variation of the voltage of plus minus 10%, and it is a three phase 4 wire and frequency is 50 Hz. And output voltage under float conditions, which is 241 volt maximum, and the each individual cell can be charged up to voltage of 2.25 volt, and the starting current which is taken from the battery bank is 25 amperes, and under fully charged condition it will take continuously a minimum charging current which is called the trickle charging current. And under boost mode, the starting current will be from 28 ampere, and the battery of each cell can be charged up to 2.35 volt, and the finishing current, that is the after all the battery unit is finished, the fully charged condition under boost mode will be 2.75 volt, and under this time the charging current will be 14 ampere. So there are 107 number of cells, and the capacity of the battery charger is battery bank is 200 ampere. This may be different for different battery bank. So this is the nameplate details of the battery charger. So under float charging conditions, the charging current which is taken is trickle charging current, and at the same time it will supply the required load to the DC-DB. So each cell is charged up to voltage of 2.25 volt. So thereby the total voltage of the battery bank will be 107 into 2.25, which is 240.75 or 241 volt. Now under boost charging mode, since each of the individual cell will charge from 2.35 volt up to 2.75 volt, so voltage across the load under boost charging mode can be 107 into 2.75, which is 294.25 volt. But all the relays are designed for 240 to 200, maximum of 260 or 270 volt. So that is why tap cell is used, so that under boost charging mode the tap cell voltage will fall under the load or under the DC-DB. So here the blocking diode will be activated, and the tap cell voltage will fall to the load of the DC-DB through the blocking diode. So here the load voltage will be 87 into 2.75 is equal to 239.25 volt. So friends, if you like my video, then do subscribe my channel, and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video.